Okay, let's look at this problem. A ball is thrown upwards with a velocity of 40 meters per second at the top of a 100 meters high cliff. Okay, we can approach this problem using the safe approach. Okay, where S is to draw a sketch, and this is already given in the question. Next, we want to assign a sign convention. This ball goes up and down, so we can choose either upwards or downwards as positive. I'm going to choose upwards as positive. Okay, indicate next to my diagram. Next, I would like to look at all the variables, known and unknown, and assign them with suitable variables. So this ball is thrown upwards with a velocity of 40 meters per second. This will be the initial velocity, right? So I can write down u is equals to 40 meter per second. Next, the ball is thrown at the top 100 meter high cliff and eventually reaches the ground. So this represents sort of displacement. For displacement, we have to choose where is the 0 meter position. Okay, I could choose either top of the cliff or the ground as 0 meters. Okay, so I'm going to choose top of the cliff to be 0 meters. This is the start of the motion. At the end of motion is at the ground, so the displacement will be represented by an arrow downwards, and this will be minus 100 meters. The negative sign shows that this displacement is pointing downwards, while our sign convention is up is positive. So I can write down displacement is minus 100 meters. What is not usually stated in such a question is the acceleration due to gravity. Okay, acceleration of gravity is acting downwards due to Earth's gravitational force. Since up is positive, so this will be minus g or minus 10 meter per second square. Acceleration of gravity near the Earth's surface. And now we are left with just the unknown. Find the time the ball takes to reach the ground for the entire journey. So t is the unknown. Given all these four variables, right, the easiest, most straightforward equation we can use will be s equals to ut plus half at squared. So now we can do a substitution of the values. Minus 100 meters, initial velocity 40, t is the unknown, acceleration is minus 10 t squared. Okay, so we will take some time to simplify this equation. There's a half there, so we multiply by 2. Simplify the equation first. And the common factor of 10, divide throughout by 10. And bring all over all the variables to one side equation. And we are going to get a quadratic equation. T squared minus 8t minus 20 equals to 0. We can apply the standard solution for quadratic equation, or where possible we can attempt to do a factorization as well. So in this case, we could have t plus 2 multiplied by t minus 10 to give us the factorization of a quadratic equation, and this will give us t is equals to minus 2 seconds or t is 10 seconds. Now since time is forward from 0 second onwards, so this t is equal to minus 2 seconds is what we say is inadmissible, not allowed. Okay, and therefore the answer we'll have for this part A will be 10 seconds, since minus 2 seconds is inadmissible. So once we've found the time, we can proceed to do Part B, find the velocity at which it hits the ground, v. Okay, so this velocity will be over here. Among the equations of motion, the simplest equation is v is equals to u plus at, and we have the necessary known values to find v directly. Initial velocity u is 40, acceleration is minus 10 meter per second square, and the time we have is 10 seconds. That gives us a velocity of minus 60 meter per second. So the magnitude of this velocity is 60 meters per second. Negative sign indicates that this velocity is downwards. Right, and this is the solution we have using equations of motion. Okay, now we can also represent this entire motion using a velocity time graph. Okay, we have started with a velocity time graph, meter per second, time in seconds. It was thrown upwards with 40 meter per second. Okay, we might want to label the motion of this graph. A is the ball leaves at A, reaches the highest point at B. You can show this on our graph. This is A, highest point B, velocity is 0, and the ball comes back to the same level C before it reaches the ground at D. So C could be somewhere around here, and D could be the end of the motion is over here. Okay, so try to represent the rest of the motion. So when it goes up from A to B, and B to C, the distances covered are the same. So this area under the graph and this area should be the same. Okay, my diagram is not to scale, so this should represent the same distance up and down, same distance covered. Okay, and then from C to D, this is additional distance covered from the top of the cliff to the ground, and this should represent our displacement. This area is below the time axis, that's why it's negative 100 meters. Right. In our description earlier, right, we acknowledged that the acceleration is negative because up is positive, so downwards negative. So this gradient will be negative 10 meter per second square, and this actually represents the motion of our ball from A all the way to D, and when it reaches D, right, this will give us the final velocity of minus 60 meter per second when it just hits the ground.